This is the first problem on the extra practice worksheet I gave you for chapter 4 in case you're not sure how to do it. So, get my pen open here. I've got a gorilla that's 445 kilograms, that means 450 newtons. He's got a vine hanging up this way at 15 degrees and another one he's hanging from at 55 degrees. And so if I draw a free body diagram, it's going to be, I'll call that F T1. And this one I'll call F T. Now I have 450 newtons pointing down. All right, I'm going to change colors here. So up this way, I've got a Y, and up this way, I have a Y. So these are two-dimensional forces. I have to divide them into X and Y's. And I know this angle here is 15 degrees. This one is 55 degrees. So this one is the sine because it's opposite. So it's going to be F T1 sine of 15 degrees. If I get my calculator and do sine of 15 degrees, that's 0.26. So basically, this Y force is 0.26 FT1. This one is FT2 sine of 55 degrees. If I get my calculator out and do sine of 55 degrees, I'll get 0.82. So I'm going to multiply 0.82 times FT2, which would be 2. Those two added together have to equal 150. The y down has to equal the two y's up. Always true. Let's finish the triangle. There's also an x force here. That's the cosine because it's adjacent. That's going to be FT1 cosine of 15 degrees. So I get my calculator out, and be sure I'm degree mode, and do cosine, enter cosine 15 degrees, I'll get 0.97. So 0.97 FT1. This one points to the left. That one is the hypotenuse, which is FT2 times the cosine of 55 degrees. My calculator, if I get it out and enter cosine 55 degrees, I get 0.57 FT2. That's a 9. Okay, so to do this, I know the two x's have to be equal. The two greens have to be equal because they're opposite, it's not moving. And the two ups have to equal the one down. So let's write out the equations. 0.57 FT2 equals 0.97 FT1. Two unknowns, don't know either one of those, FT2s or FT1. So let's get our other equation. 0.82 FT2 plus 0.26 FT1 must equal 450 newtons. All right. So if I divide, I'm going to try to find FT1, or actually FT2. So I'm going to divide both sides by 0.97 here. When I do that, I'm going to get FT1 equals 0.57 divided by 0.97 gives me 0.7 basically. FT2. I'm going to take this right here and I'm going to substitute it in right there. So 0.82 2. This is called systems of equations. Plus 0.26 times 0.70. FT2 has to equal 450 newtons. 0.26 times 0.27 gives me 0.182. So yeah, I believe that's right. 0.182 FT2. This is still 0.82 FT2. That equals 450 newtons. Add those two together since they're both FT2, and I get 1.002 FT2 equals 450 newtons. So FT2 must equal 449 newtons. That's one of my answers. To get the other answer, I take 449, I'm going to put it right back into that equation. And 0.7 times 449 gives me 314. So FT1 equals 314 newtons. That is how you do a static problem where nothing is moving.